Today we are going to learn about the respiratory physiology. Respiratory physiology, in this we are basically our first topic will be the mechanics of breathing. We know the lungs are mainly used for our exchange of gases. There's a oxygen which comes in and then the carbon dioxide which exhales out. Now, what is the process? How it do? So there is a physiology behind it. So this is a structure of a lung, where this is a trachea, and then we have lungs, and then we have a this one is a pleural cavity. This one is a visceral pleura, and then a parietal pleura. This one is a parietal pleura, and then we have a in between that is a pleural cavity. This is a most important muscle, which is a diaphragm. Now, what happens? This A, what is the pressure inside the lungs will be the intrapulmonary pressures, and the B, which is the pressures in between the pleural cavity, is the intrapleural pressure, and the C is the atmospheric pressure, which is equivalent to the 760 mm of Hg, and the intrapleural pressure, which is also equivalent to 760 mm of Hg, and the pleural cavity is around bit negative than the intrapulmonary pressure, that is around 756 mm of Hg. So we can designate intrapulmonary pressures as 0, atmospheric pressures as 0, and intrapleural pressures as -4. And now we should understand why the intrapleural pressures are being negative. The lungs being an elastic structure, because of the lung elasticity, it has the tendency to collapse, and the chest wall has the tendency to go out. So if the visceral pleura, which is attached to the lungs, try to recoil back with the lung, and the parietal pleura, which is attached to the chest wall, try to recoil out, the inside pressure will be negative, which is around -4. Okay. Now, to understand the pressures which has been taking place, what are the pressures which happens in the lung, we should understand some terminologies. Now, at rest, basically, there are few pressures which will be there. That is called transpulmonary pressures. That is transpulmonary pressures. Now, what is the transpulmonary pressures? It is the intrapulmonary pressure minus intrapleural pressure. Now, intrapulmonary pressures is 0 and intrapleural pressure is -4. That is equal to about +4. So, +4, these are the pressures for inflation. Now, transthoracic pressure, this intrapleural pressures is -4 and atmospheric pressure is 0. So what will be there? It is -4. So these pressures are the deflating pressures. And respiratory pressure, which is pulmonary pressures minus atmospheric pressure, which will be 0. Now we have a midbrain. Now understand how the signals for inspiration comes. Now this was all about at rest. Now when it comes to inspiration, which is an active process, so what happens is there are excitatory signals from medulla, which excites with C3, C4, C5, which is basically the phrenic nerve, and the neurons at the T1 to T11, okay, which supplies to the external intercostal muscles. And there are also a group of neurons which is called ventral respiratory groups, which also supplies signals to the external intercostal muscles. Now together these excitatory signals send impulses to the diaphragm and external intercostal muscles. Now when these contract, when the diaphragm and the external intercostal muscle contract, there will be, these are the lungs and these are the pleural cavity. Now whenever this is the diaphragm and external intercostal, whenever these two, the diaphragm and the external intercostal muscles contract, there will be increase in the pleural cavity. Okay, there will be increase in the pleural cavity. Now the volume increases, then according to the Boyle's law, the volume, if volume increases, the pressure decreases. So the intrapleural pressure decreases. Because the intrapleural pressure decreases, and along with that the visceral pleura also try to get stretched, the intrapulmonary pressure get recoiled back, though pulmonary pressures also decreases. The atmospheric pressure remains same. So with the contraction of external intercostal muscles, it will increase the anterior posterior diameter of the thoracic cavity. And with the contraction of the diaphragm, there is increase in the horizontal horizontal increase in the thoracic cavity, which is basically like a bucket handle movement. So these together will increase the thoracic cavity, which will decreases the intrapleural pressure and intrapulmonary pressures. Now suppose in inspiration, with inspiration, our at rest the intrapleural pressures was minus 4 mm of Hg, and with the contraction of these two muscles, the intrapleural pressure decreases to minus 6 mmHg. Pulmonary pressures, which was 0, it increases to plus 1 mm of Hg. Now what happens to the transpulmonary pressure? Transpulmonary pressures, which is pulmonary pressure minus intrapleural pressure. Now what is the pulmonary pressure? Which is plus 1, and intrapleural pressure is minus 4. So which is plus 4 and which is 5, plus 5. So this transpulmonary pressure increases. Now what is transthoracic pressure? It is minus 6, which increases to minus 6 intrapleural pressure, and atmospheric pressure remains same, so it becomes minus 6. So initially it was minus 4, now it is minus 6, so it decreases. The deflating pressures decreases and inflating pressures increases. And the respiratory pressure, which is pulmonary pressure decreases. P pulmonary, which is plus 1 minus 0. So pulmonary pressure decreases. Pulmonary pressure decreases. So it is minus 1. So it transrespiratory pressure decreases. So basically in a lung, the inflating pressures increases and the deflating pressure decreases. Thus inside the lung there will be negative pressure, outside the lung it is positive pressure. So what happens in inspiration? The air flows from a higher pressures to a negative pressure. So it happens, what happens is the air flows inside the trachea now. Okay, this is during the inspiration process, which is an active process. Now, what happens in forced inspiration? When it is a forced inspiration, not only the external intercostal diaphragm muscles contract, but also the scalene, sternocleidomastoid, pectoralis minor muscles contract, thus increasing more of the thoracic cavity volume, thus decreases more of the intrapulmonary pleural pressures, more decrease in the pulmonary pressures, and thus more increase in the transpulmonary pressure, more decrease in the thoracic pressure, thus more increase in the inflating pressures, and thus decreasing in the transthoracic pressure, thus more active in forced inspiration, the more air goes inside the lung. This is all about our inspiration part. Now, what happens in the expiration? There is no muscles involved in expiration. That is quiet expiration, which is a passive process. Whenever the pulmonary pressures becomes equal to atmospheric pressure, the inspiration stops. Once the lung is full of air, now what happens? The pulmonary pressures increases. Pulmonary pressure increases and pulmonary pressures increases and also the intrapleural pressures increases. Why? This is later on. So once this intrapulmonary pressures increases, because the air will flow inside the lung, and now the intrapulmonary pressures increases. Now once the intrapulmonary pressures increases, there is a stretch receptors which get activated, and this will send a signal to the medulla. Now the medulla will send inhibitory signals to the external intercostal muscles and the diaphragm. Now during the diaphragm and the intercostal muscles who have been contracted in inspiration, now they get relaxed. Now when it get relaxed, it decreases the thoracic volume. Now it decreases the volume, what happens? Pressure increases. Now the intrapleural pressure increases. Atmospheric pressure remains the same. Now once it happened, now what happens? Because the intrapulmonary pressure increases, intrapleural pressure increases, transpulmonary pressure decreases. Example, transpulmonary pressure. Now, as I told you, the pulmonary pressures increases. So it is +1. Now the intrapleural pressure, it increases. So if it is minus, it was -6 when it was this, sorry. Okay. Now it is the pulmonary pressures increases. So it was 0 at time of rest, and with inspiration it increases to 1. Okay, that is +1. Now minus this pleural pressure, it increases. So it was -6 at the time of active inspiration. Now it increases. It increases means it decreases to around 4. Now it is -3. Now the transpulmonary pressure decreases. So our inflating pressure decreases. The same way the transthoracic pressure increases. Why? Because the pulmonary pressures, the transthoracic pressure is pulmonary minus atmospheric pressure. The pulmonary pressures increases. In transthoracic, the pulmonary pressure increases minus atmospheric pressure, so it increases. It is deflating pressure increases. Now with that, our because of the transthoracic pressure, the deflating pressure increases. it deflates and the air will start, and the pressure inside the lung, it increases than the atmospheric pressure. Now the air will flow out of the lung until unless the pulmonary pressures becomes zero. So this is a in case of quiet expiration. Now what happens in forced expiration? In forced expiration, the muscles involved will be the external oblique, internal oblique, transabdominis, rectus abdominis, and the internal intercostal muscles. These all together muscles will contract and increase the intra-abdominal pressure. Once the intra-abdominal pressure increases, it causes more decrease in the thoracic cavity, and more decrease in the thoracic cavity will cause more decrease in the transpulmonary pressure, more increase in the transthoracic pressure, and more increase in the respiratory pressure. So what together it will cause, what happens, the more air will be exhaled out. So this is all about our inspirations. I have told you about what happens in the at rest, what happens during the inspiration part, and what happens in the expiration. So in the next video we'll learn about what the compliance and the airway resistance.